Okay guys, today we're going to, or I'm going to explain you the exercise number 45, which says you throw a ball straight up with an initial velocity of 15 meters per second. It passes a tree branch on the way up at a height of 7 meters. How much additional time will pass before the ball passes the tree branch on the way back down? What does it mean in Spanish? Well, the translation is lanzan una pelota hacia arriba con una velocidad inicial de 15 metros sobre segundo. Pasa por una rampa cuando va de subida, pasa por una rama cuando va de subida, o al lado de una rama cuando va de subida, y la rama está a 7 metros de altura. ¿Cuánto tiempo adicional tendrá que pasar antes de que vuelva a pasar por la misma rama cuando vaya de caída? Bueno, entonces vamos a empezar a hacer este ejercicio. Okay, so let's see what is data that we have. Here I copy the formula that we may need. So I'm going to write here, I'm going to write down here the data that we have. And according with the data, we're going to know which formula we're going to use. Okay, one of the things that we have is the final height. Una de las cosas que tenemos es la altura final. It's 7 meters, and we can assume that the initial height is 0 meters. Ya que podemos asumir que la altura inicial es 0 metros, ya que nadie nos está hablando de la altura del lanzador ni nada por el estilo. Simplemente se está diciendo que están lanzando hacia arriba un objeto. And we also have the initial velocity. It is 15 meters per second. And this time we're going to consider it as positive because they're throwing the object, in this case the ball, upward. Vamos a considerar la velocidad inicial como positiva, ya que están tirando hacia arriba a la pelota. Finalmente, la gravedad. We're always going to have the gravity, which is minus 9.8 meters per second. Remember that we always are going to work with the gravity as negative because the gravity pulls you downward. Siempre vamos a trabajar con la gravedad como negativa, ya que la gravedad es una aceleración que va en sentido, o mejor dicho, que va hacia abajo. Entonces, vamos a ver cuáles fórmulas nos pueden servir y cuáles no. I'm going to start with the first one. In the first one we have the final height. We have the initial height. We also have the initial velocity. We don't have the time, alright, but they're asking us the time. No tenemos el tiempo, pero no los están pidiendo. We have the gravity, and once again, we don't have the time. Alright, this, it could be the suitable formula. Esta puede ser la fórmula adecuada para esto. Shall we work with another one? I don't think so, because if we take a look to the second formula, we don't have the final velocity, neither the time. So there are two things here that we don't have. En esta no nos hubiera convenido porque hay dos cosas que no tenemos. Entonces no hubiera valido mucho la pena. The same here, we don't have the final velocity. Yes, we have the initial height, and the final height, and the initial height, and also the initial velocity. So the only thing we don't have here is the final velocity, but that wouldn't work. It will take a longer way. Hubiera tomado un camino más difícil. Yo creo que la opción correcta, la más fácil, podría ser esta de aquí, así que vamos a usarla. Let's replace all the data that we have. We already have the final height, which is 7 meters. Which is equal to the initial height, 0 meters, plus the initial velocity, 15 meters per second. We don't have the time, so we copy it there, plus the half of the gravity, which is minus 9.8 meters per squared seconds, multiplied by the time squared. Alright, so let's start solving this. Here we have 7 meters equals 2. Remember that when you add or subtract 0, it won't affect anything. Cada vez que ustedes suman o resten 0 no va a afectar en nada, así que lo podemos cancelar de una vez. We copy here 15 meters per second times the time, 15 metros sobre segundo por el tiempo. And here we have positive multiplied by negative is negative, and the half of minus 9.8, it is 4.9. La mitad de 9.8 es 4.9, o un medio multiplicado por 9.8. 4.9 meters per squared seconds times the time squared. Alright, as you can see here, our unknown is a t, the time. Como pueden ver, nuestra incógnita aquí es el tiempo. Aquí está sin un cuadrado y aquí está con un cuadrado. ¿Qué quiere decir esto? Que estamos manejándonos con una ecuación de segundo grado. Toda ecuación de segundo grado debe ser igualada a 0. ¿Qué quiere decir esto? Que este 7 metros que está aquí, vamos a pasarlo al otro lado. Nos quedaría menos 7 metros más 15 metros sobre segundos por el tiempo menos 4.9 metros sobre segundos al cuadrado todo eso igual a 0. Now I'm going to rearrange this equation so it looks more pretty or prettier, which could be impossible. How can that be pretty, that horrible equation? Vamos a rearreglar o reordenar los elementos de esta ecuación de modo tal que se vea más bonito, si eso puede existir, ya que es una ecuación. No sé dónde y cuándo una ecuación puede ser bonita, pero bueno, a veces pasa. Okay, minus 4.9 meters per square seconds times the time squared plus 15 meters per second times the time minus 7 meters equals to 0. Okay, now I'm gonna give names here. Remember, this is an equation of second degree. Esta es una ecuación de segundo grado. So we must use this horrible formula. T equals to minus B plus or minus the square root of B squared minus 4 times A times C, and all of that divided by 2 times A. Who's going to be A, B, and C? ¿Quién va a ser A, B y C? A va a ser el factor que multiplica T al cuadrado, minus 4.9 meters per squared second. B is going to be 15 meters per second. And C is going to be minus 7 meters. Now we have to replace all of these values in that horrible formula. Hay que reemplazar todos esos valores en esa espantosa fórmula. So we have T is equal to minus B. It will be minus 15 meters per second. Plus and minus the square root. here it goes. Okay, b squared is 15 meters per second squared. Minus 4 times a. A is equal to minus 4.9 meters per square second times c, which is equal to minus 7 meters. And all of that divided by 2 times a, which is equal to minus 4.9 meters per square second. Oh my god, this is so long. And I ran out of space. Ya se me acabó el espacio. Así que voy a seguir aquí arriba. Better. Okay, here we go. T is equal to minus 15 meters per second. Sorry, I made a mistake there. There, 15 meters per second plus and minus. Alright, and let's start here inside the square root. Vamos a empezar aquí dentro de la raíz cuadrada. 15 squared is 225. And since you raise the number to the square, you have to do the same with the letters or the units. Ya que elevaron el número al cuadrado, las letras también van a quedar metros al cuadrado sobre segundos al cuadrado. Now, here it goes, this awful multiplication. Ahora viene la multiplicación fea. Let's start with the signs. Negative multiplied by negative is positive, and positive multiplied by negative is negative. Now, 4 multiplied by 4.9 multiplied by 7 is 137.2. 4 por 4.9 por 7 son 137.2. Now is the time of the units. Ahora vienen las unidades. Meters multiplied by meters is squared meters. Metro por metro es metro al cuadrado. Sobre segundos al cuadrado. And all of that divided by 2 times 4.9, which is equal to minus 9.8 meters per square seconds. Okay. One day we will finish it, don't worry. Minus 15 meters per second plus and minus the square root of 225 minus 137.2 is 87.8 meters, square meters per square seconds. Once again, all of that divided by 9.8 minus 9.8 meters per square second. Oh, it seems it's never going to end this exercise, but we will. Don't worry. Okay, once again I ran out of space. Se me acabó otra vez el espacio. Doesn't matter. Okay, here it goes. T is equal to minus 15 meters per second plus and minus and the square root of 87.8 is 9.37. And here it's going to happen something really interesting. This square is cancelled with the root. Ese cuadrado se cancela con la raíz. And the same happens with the square of the second. It's cancelled with the root. Se cancela el cuadrado del metro y el cuadrado del segundo, quedándonos entonces metros sobre segundos. Minus 9.8 meters per squared seconds. And now you will have two solutions for t. You will have the positive and the negative, theoretically. Okay, the first one is going to be minus 15 meters per second plus 9.37 meters per second. Divided by minus 9.8 meters per squared seconds. And we also have the other solution. Let's call this one T1 and this one T2, or time 2. Minus 15 meters per second minus 9.37 meters per second and all of that divided by minus 9.8 meters per squared seconds. Alright, I ran out of space once again, but it doesn't matter. We will continue right here. Alright, here we go. Time 1 is equal to minus 15 meters per second plus 9.37 meters per second is 5.63 meters per second. And all of that divided by minus 9.8 everything disappeared. Okay, then let's continue. Alright, T1 is going to be 5.63 meters per second divided by minus 9.8 meters per square second. And the other time 2, is equal to minus 24.37 meters per second divided by minus 9.8 meters per square second. Okay guys, we're about to finish. So here it goes. T1 is equal to Oh, and I almost forgot. Here it was negative. Okay. 5.63 divided by minus 9.8 is going to be 0.57. And what is going to be the unit of this? Okay, meters are cancel each other, los metros se cancelan, and 1 second is cancelled with 1 second. Solo un segundo de abajo se cancela con un segundo de arriba y queda un segundo. What about the time 2? Okay, minus 24.37 divided by 9.8 is 2.49 seconds as well. Ok, chicos, llegamos al final del ejercicio. ¿Y qué sentido físico tiene de que hayan dos tiempos? Recuerden que había un árbol que estaba a cierta altura, esta es su rama, y el cuerpo fue lanzado. Entonces, el cuerpo es lanzado con esa velocidad inicial y llega aquí a la rama a los 0.57 segundos. Pero el cuerpo que fue lanzado, la pelota, siguió de largo hasta arriba, hasta cierto punto, el cual no nos dijeron cuál era, pero sabemos que en algún momento va a regresar. Y cuando pasa por la rama otra vez, lo hace a los 2.49 segundos. Por esa razón es que hemos hallado entonces dos tiempos. El tiempo en el cual pasa la pelota de subida es a los 0.57 segundos. Y a los 2.49 segundos vuelve a pasar por ahí, pero en esta ocasión de bajada. Okay guys, that's all for this video. I know it's very long, but if you watch it again, I know you will understand it, and if you have any doubts, just let me know it. Goodbye, and I'll see you next time on the next video.